Alright, in this video we're going to talk about radical expressions. So let's go ahead and get started. So if I start with 5 and I ask you to square it, that would be 5 squared, and you'd get 25. And so now what if I take the square root of 25? Well, what does it mean to take the square root of 25? It means you're looking for some number that you square and you get 25. And of course that would be 5. So we would say that, well actually let's just see here. The other thing I want to mention here is it's also true that negative 5, when you square it, you get 25. And so 5 and negative 5 are actually square roots of 25. But when we use this symbol, we actually limit ourselves to just the positive case. And so we call this the principal square root. So notice taking the square root of a number is the opposite of squaring a number. That's going to be important. And our official definition is c is the square root of a if c squared equals a. So again, in this case, notice 5 squared is 25, and so is negative 5 squared. And so these are both square roots of 25. But again, when we use this radical symbol, we're going to limit ourselves to the non-negative square root. So for example, on 4a, the square root of 49 is 7, since 7 squared gives us 49. And again, it's also true that negative 7 squared is 49, but when we use this symbol, we actually limit ourselves just to the positive case. Alright, so let's continue on now. So here the square root of 64, and by the way, you might want to try doing these all, or do as many as you can, and then watch the video and see how you did. So here, be careful, because this is really like negative 1 times the square root of 64. The square root of 64 is 8, and when you multiply by negative 1, it's going to be negative 8. On the other hand, if you're taking the square root of negative 64, you're looking for some number that you square, and you get a negative 64. Well, we don't have any numbers like that, at least not yet. We would say this is not a real number. Now, square root of 25 over square root of 81, square root of 25 over 81, we're looking for some number that you square, and you get 25 over 81. Well, the 5 in the numerator, if you square, that would be 25. And if you put 9 in the denominator, 9 squared would be the 81. Remember, this means 5/9 times 5/9. And so our answer here is 5/9. Now later on we'll talk about a property where we can break this into two radicals and we get the same thing, 5/9. That's the way we normally do it. Alright, E and F are interesting problems. Now when you square 6 you get 36, and the square root of 36 is 6. But there's another way to think of it. Remember, we discussed how taking a square root is the opposite of squaring. And so if you square 6, you get some number, and then you take the square root of that number. That undoes what you just did. Squaring a number and taking a square root undo one another. They're opposites. And so that's why this is going to be 6. Same thing happens here. These are opposites. They basically cancel each other out. You get 13 here. All right, now we're looking at the cube root of 125. So similar to the one we were just doing, or the ones we were just doing, but instead of looking for something we square to get 125, we're looking for a number that we cube to get 125. And you know, 5 to the first power is 5. 5 squared is 25. Notice 5 cubed would be 125. So the cube root of 125 is 5. So if you haven't already tried h, I would encourage you to try it. Notice this time it's a fourth root. The other thing I want to mention is with square roots, this is actually a 2 here, but we don't write the 2. It's just understood to be a 2. But with any larger roots, we'll put the root right there. All right, so here we're looking for some number to the fourth power that's 16. Well, it's got to be pretty small. It turns out it's 2. So one of the things you're going to find, and we've already seen this before, is we need to know our perfect squares. We know 1 squared is 1, 2 squared is 4, 3 squared is 9. And again, we should know all the way up to, we talked about this before, 12 squared, which is 144. You also should know your cubes. 1 cubed is 1, 1 times 1 times 1. 2 cubed is 8. 3 times 3 times 3, 3 cubed is 27. 4 cubed, 4 times 4 times 4, you would get 64. And then we just talked about 125. These are the ones you should know. And then I would just say, as far as fourth powers, there's 2 that you ought to know. 1 to the fourth power is 1. There's 3, I guess. 2 to the fourth power, we just saw that that's 16. And 3 to the fourth power, well, if you multiply 4 3s, you could pair up your 3s, you get 9 times 9, or 81. So these are the ones that you want to get to know, because when you're working with roots, it'll help you to be able to solve the problems. All right, so let's look at number 5 here. It says in the radical expression, the cube root of 5, the 5 is referred to as the radicand, and the 3 is referred to as the root. Actually, the index is the word they usually use, but they also use the word root. And since we say the cube root of 5, I call it the root. So it's the root or the index. So the 5 is the radicand, the 3 is the root or index. On number 6, it asks you to estimate the value of the square root of 17 without using your calculator. You might want to stop the video and take a shot at that. Well, square root of 16 is 4. We also know the square root of 25 is 5. And so 17 is pretty close to 16, a lot closer than 25. And so I would think it's approximately, just a little bit more than 4, maybe 4.1 or 4.2, something like that. That would be a good estimate. You could actually get on your calculator and, let's see, I didn't do that yet. Square root of 17. And that's 4.12, so that's pretty good estimates. All right, number 7, use your calculator to find the square root of 57. I would encourage you to also try number 8, find the 5th root of 20. These are things you ought to be able to do on your calculator. On number 7, you should get 7.5498. Notice it's set to 4 decimal places. And on number 8, you should get 1.820, and I don't know if that's a 5 or a 6, so we'll just do it on here. Let's see, you guys have a graphing calculator, so let me get mine. All right. Let's see if we can get this. Oh, I know what I need to do. Second. There we go. Okay, so let me clear my screen. We'll do square root of 57. So we want to hit second and the x squared button. Notice the square root right above. So that'll be the square root of 57. And we do get 7.5498 when you round to 4 decimal places. Now the fifth root of 20 is a little bit different, kind of weird. You're going to actually put in the root first, which is 5. And then you'll do your math menu. And notice right here, this is the xth root of whatever you put inside of it. But again, we've already put the 5 in, that's the root. But let's go ahead and hit option 5 here. This is the fifth root of 20. Let's arrow out of there and hit enter. And you get 1.820. It looks like it's a 6. All right, so that's going to be it for the calculator for now. All right, let's move on to number 9. So in each case here, we're just evaluating the function for a given value. So for f of 0, we'll plug in 0. You're going to get 0 plus 6, that's the square root of 6. To find f of 1, we would plug in 1. Three plus 6, that's square root of 9, which we know is 3. So f of 1 is 3. And then finally, f of negative 3. Notice that's 3 times negative 3, that's negative 9 plus 6. That's square root of negative 3. Remember, we can't take the square root of a negative number because there's no number we can square to get negative 3. And so this is the case where this is not a real number. All right, let's move on. I think we'll do one more problem here. So we were just talking about, or we were just plugging in values into radical function. Here we're actually going to graph. It says graph each of the following by plotting points. Let's see. So first of all, let's make an xy table for f of x equals the square root of x. So let's try plugging in 0. The square root of 0 is 0, because 0 squared is 0. So 0, 0 is on the graph. Let's plug in 1. Notice when you plug in 1 here, you're going to get 1. Square root of 1 is 1. Now we can plug in 2, but it turns out to not be a very good choice. You'd have to throw that into your calculator, and it's about 1.4. Square root of 2 is about 1.4. So I don't really like getting a decimal number like that when I'm plotting points. So think about this. If I plug in 3, square root of 3, that's also not a nice number. It'd be about 1.7. But how about 4? If you plug in 4, you're going to do the square root of 4, and the square root of 4 would be 2. And so normally, this is where we stop. Now, you might think, well, what about negative numbers? Well, we talked about how we can't plug in a negative number under the square root because there's no number that you can square to get negative 1. And so we can't plug in any negative numbers in. And so our graph is just going to be limited to positive values of, well, the x values are all going to be positive, either 0 or positive. So the graph looks something like this. I call this the ET function. So it starts here and it goes off to the right forever. It does keep rising even though it does rise slowly. Let's go ahead and plug in some numbers here. So we're just graphing by plotting points. This was y equals square root of x. What if we got to find the square root of x plus 2? So again, let's plug in 0. G of 0 is the square root of 0 plus 2, which is the square root of 2, which we said was about 1.4. By the way, I do want to point out, notice 2, 1.4, my graph's a little bit off, but that point's on the graph. It's just not at a nice point. So we're not getting a really nice one there. Let's go ahead and plug in 1. We get the square root of 1 plus 2, which is the square root of 3. So when we plug in 1, we get, it's about 1.7. Well, let's keep on going. How about if we put a 2 in there? G of 2 is the square root of 2 plus 2. And so that's square root of 4, which is 2. So 2, 2 is on the graph. Let's see. Now, if we plug in 3, we'd be taking the square root of 5. If we plugged in 4, we'd be taking the square root of 6. See, really the next perfect square is 9, so I'd like this to be 9. So I think a good choice would be 7. So if we plugged in 7, we get the square root of 7 plus 2, square root of 9, which is 3. And so there's another nice point. And I think I want to plug in, let's go ahead and plug in another one here. How about negative 1? Notice if you plug in negative 1, you get the square root of negative 1 plus 2. That's square root of 1, which is 1. So let's plot these points. I'm just going to do the nice ones. We got negative 1, 1. We've got 7, 3. We've got 2, 2. So it's going off like this. Let's try negative 2. So g of negative 2, we get square root of negative 2 plus 2. That's square root of 0, and you get 0. So negative 2, 0 is on the graph. And in fact, notice that at that point we're taking the square root of 0, which is 0. If you plug in a smaller number, like negative 3, negative 3 plus 2, now you are taking the square root of a negative number, negative 1 there. And so this negative 2 is the smallest number that you can plug into that graph. This is the graph of G, and this was the graph of F. So notice the difference in the graphs. They're pretty much the same shape. It's just this graph has gone 2 to the left. So we'll talk more about that later. Now, number 11, it says find the domain. So I want to just point out something here. The domain here for the square root of x was x is greater or equal to 0. It can either equal 0 or be positive, greater than 0. So that's your domain. We could also write that as 0 to infinity. So what about a function like this here? Well, what we've learned, so we have the square root of, or f of x equals the square root of x minus 5. We need x minus 5 to be greater or equal to 0. If you solve for x, you get x is greater or equal to 5. So our domain here is 5 to infinity. So all we need to do is take our radicand. We know we can't take the square root of a negative. We can either equal 0 or we can be greater than 0, which is positive. So set this greater or equal to 0 and solve for x, and that's how you get your domain. So you might want to try that for part B and then watch the video. So our radicand needs to be greater or equal to 0. It's either equal to 0 or positive. So we'll subtract 6 on both sides. We get 3x is greater or equal to negative 6. Divide by 3. We're going to end up with x is greater or equal to negative 2. And so our domain is negative 2 to infinity. Now, let's go back to this first one here. Notice 5 is in the set. If we found f of 5, it'd be the square root of 5 minus 5. That's the square root of 0, which is 0. No problem. How about something bigger than that, like 6? Could be anything bigger than 5. Well, 6 minus 5 is 1. We'd be taking the square root of 1. No problem. What if we pick something that's not in here, like 4? Well, f of 4 would be the square root of 4 minus 5. We'd be taking the square root of negative 1. We can't do that. So only numbers starting at 5 and larger can be plugged into this so that you're not taking the square root of a negative number. All right, I'm going to go ahead and stop the video here, and I'll do a second video for the remainder of the lesson.